We used purple and red urchins as our specimens for our experiment. Ours were found in various intertidal zones in Coos Bay, Oregon. They're extremely abundant in Oregon because their main predator, the sunflower sea star, has been wiped out by the sea star wasting disease. The purple and red sea urchins use cryptic behavior using whatever debris they can get their spines on to cover themselves. This behavior has been linked to various levels of light exposure. Our lab setup consisted of 5 small containers set in a larger tank with flowing ocean water. We placed debris made up of plastic, shells, and seaweed into the containers. We performed trials with intense light and trials with covered darkness, placing 1 urchin in each container for periods of an hour and a half, alternating between our purple urchins and our red urchins. We let our urchins rest in neutral light for at least an hour and a half between trials. After each trial, we assessed how much the urchins had exhibited cryptic behavior by determining how much they had covered themselves up using the debris in their containers. In our data, we convey this information using percentages of coverage. We hypothesized that both the purple sea urchin and the red sea urchin are more likely to exhibit cryptic behavior when exposed to higher intensity light sources.
In this graph, it is shown the average percent coverage between purple and red sea urchins after their exposure to an hour and a half of high-intensity light. As you can see, the purple one's average cover when exposed to high-intensity light is around 65%, while the red is around 25%. This shows a very significant difference between the amount of cryptic behavior between the purple and red urchins, with a p-value of 0.0052. In this next graph, it is displayed the average percent coverage between purple and red sea urchins after their exposure to an hour and a half of darkness. As you can see, the bars are about equal, both rounded to about 30%. This shows that between the two species there is not much variation in their cryptic behavior. The p-value for this was 0.868, which shows there is not much statistical difference. Finally, when all the data was collected, both variables of color and lighting were put together to show the overall findings. The purple urchins supported our hypothesis by showing a statistically significant difference between the amount of covering behavior in light and dark stimuli. The p-value for this was 0.0029, which is less than 0.05 and supports that light may play a factor in urchin covering behavior. On the other hand, the red sea urchins did not show much difference in either stimuli, with a p-value of 0.96. This is still important to note, though, because this shows there should be further testing done to find out why the red sea urchins are triggered to use cryptic behaviors.
So what does this all mean? We see a clear difference between the light and dark trials with the purple urchins, which implies that their covering behavior is strongly controlled by the amount of light they are exposed to. On the other hand, the red urchins showed very little correlation between their covering behavior and the light they were exposed to. If more trials were run, we may have noticed a heavier trend in our results. The strong response in the purple urchins was very promising.